Okay, welcome and thank you for joining. Thank you for joining us today. My name is Jeroen van Bouwel and I serve as director of XEIKON's Global Innovation Center. And over the past 25 years, I've had the opportunity to work extensively in the digital printing industry, focusing mainly on developing high-performance solutions for demanding and highly regulated applications. And throughout my career, I've collaborated with label converters, with security printers, with government organizations, with brand owners around the world. And a recurring challenge I've seen across all markets is how to respond to increasing complexity, more information, more regulations, more SKU stock keeping units, while maintaining efficiency and profitability in your workflow. And bridging that gap between evolving market requirements and the advancing capabilities of digital printing systems and workflows has been at the core of my work. And today, we will explore how digital printing enables a new level of flexibility in label production, and particularly when it comes to extended content labels. Later on, I will often use the abbreviation ECL, extended content labels. As regulations expand, product information grows, brands look for new ways to engage customers. The ability to integrate extended content seamlessly into your workflow becomes a strategic advantage rather than just a technical feature. And in this XEIKON Innovation webinar, I will share some practical insights into how extended content labels can be designed and can be produced efficiently, and how they can be fully integrated into a digital printing workflow to unlock flexibility, compliance, and differentiation. Let's dive in. And let me briefly walk you through how I would like to structure today's session and things I want to cover during this webinar. First, we will align on what extended content labels actually are. I will define them clearly, explain functional purpose, and more importantly, position their strategic relevance in today's packaging landscape. ECLs, extended content labels, are no longer just a regulatory tool. They are becoming a platform for communication, a platform for differentiation and compliance management. Setting that foundation is important before we move into the business implications. I also want to spend some time on the digital advantages, and this is where the technology discussion becomes critical. I will explain why digital printing is uniquely positioned to support this kind of extended label or extended content label production, not only from a flexibility standpoint, but also in terms of versioning, short runs, compliance updates, supply chain efficiency. And the objective here is to connect market demand with technological capability and identify where digital enables strategic value rather than simply operational convenience. And we'll also have a look at the market growth, where I will share global trends, market size evolution, and the primary growth drivers across different segments. We will examine what is structurally driving the demand, whether it's regulation, SKU proliferation, export requirements, consumer information expectations, and where the most sustainable growth pockets are emerging. And a big part of the presentation later on will be used to explain one case, an extended content label that we developed for the nutrition market, an example to illustrate every single step in the production of an extended content label. And by the end of this presentation, I hope, or I would like us to have a clear view of three things: what ECLs represent, where the market is heading, and why digital technology is structurally aligned with this growth. To begin, let's define what we mean when we talk about ECL, extended content labels. At its core, an ECL is a smart way of increasing the communication space without increasing the packaging size. Instead of enlarging the container or adding the secondary packaging, we add multiple layers, whether that's peel and reseal construction, whether it's a booklet format or folded panels, to multiply the available surface area. The primary driver is information density, and many industries today are required to communicate significantly more. Think of regulatory instructions, think of safety warnings, think of multilingual content, ingredient disclosures, traceability data, and increasingly marketing messages. Definitely in sectors like pharmaceuticals, agrochemicals, it's not just an option, it is compliance critical to add this kind of extra information to your label, to your product. Now, what makes ECLs particularly powerful is that they solve a structural constraint. The packaging dimensions are often fixed due to logistics, due to shelf presence and cost efficiency, of course. You cannot make the package bigger to add more communication space. ECLs, extended content labels, allow brands to comply with regulations, expand communication without disrupting the established packaging formats, without changing the shape of the packaging. So in essence, an extended content label is not just a larger label, it's a packaging strategy that balances compliance, communication, and operational efficiency within the existing physical constraints. And that strategic balance is exactly why this segment is becoming increasingly relevant. Now that we have defined what extended content labels are, next logical question is, why are they becoming so important? It's all about optimization, as we just discussed, optimization of the available space. The extended interaction space offered by such labels results in viable, cost-effective, convenient, and well-accepted interface between the brand owner on one side and the consumer on the other side. But we can clearly see defined 4 different drivers behind adoption of extended content labels. And the first reason that we see is branding. Packaging is not just protection, although an important part of packaging is about protection of the content, but it is also a communication platform. And brands want to tell richer stories. They want to tell stories about the product origin, about usage instructions, about certifications, about ingredients, more transparency on the ingredients, making digital links, bring the packaging or the product online, and about the brand values, and communicating about the brand values. And an ECL allows companies to expand their narrative without compromising shelf impact. The front remains clean, visually strong, an appealing message, an attractive image, while deeper layers can provide detailed engagement. And a second reason behind or after branding, a second reason is definitely in Europe, the multiple languages. And global distribution has become the norm rather than the exception. A single SKU, a single stock keeping unit, often needs to serve multiple countries, each with specific language and regulatory requirements. And without ECLs, without this kind of extended content labels, companies would need separate packaging versions, increasing complexity and increasing the inventory. ECLs enable consolidation, one base packaging format serving multiple markets, multiple regions. So that's another important reason. The third reason that we define, that we could clearly find or see, is promotion. An ECL creates additional space for campaigns, for cross-selling, coupons, interactive contents such as QR codes, digital activation, setting up a link between the brand owner and the consumer. Again, bringing the packaging or the product digital, making it digital. And this turns the label into a dynamic marketing asset rather than a static identifier. Especially in consumer goods, flexibility can extend the product lifecycle value. And then a fourth reason, finally, the sustainability. Increasing packaging size to accommodate more information means more material, means higher transport costs, and means a higher or a larger environmental footprint. Now, as discussed, ECLs allow brands to keep primary packaging compact while expanding the communication space. In addition, by consolidating the number of SKUs across the markets, companies can also reduce the waste and the obsolescence in inventory. So overall, adoption of extended content labels is not driven by a single factor. It sits at the intersection of regulation, globalization, marketing strategies, and sustainable pressure. And that combination of forces explains why the segment continues to grow. Conventional label production traditionally rewards volume and penalizes variation. And the more versions you introduce, the more plates you need, the more changeovers you create, and the higher your inventory risk becomes. And even more than in standard self-adhesive label applications, with extended content labels, that model quickly becomes inefficient. Digitally printing, that fundamentally changes this dynamic. It makes short runs economically viable and allows for multiple versions to be produced in an efficient way within the same workflow. Instead of optimizing for long static runs, you can optimize for flexibility. You produce what is needed, quantities required, without carrying unnecessary stocks. And speed is equally critical. Extended content labels are often driven by regulatory requirements or product updates. And when legislation changes or artworks need to be revised at the last minute, brands cannot afford to wait. Digital printing enables immediately implementation of those changes. There are no plates to remake, there are no pre-printed inventory to scrap. Production becomes demand-driven rather than forecast-driven. And this just-in-time capability significantly reduces obsolete inventory and gives both converters and brand owners a greater operational control. And at the same time, extended content labels demand exceptional print quality. Fine text must remain legible, even at very small font sizes. Gradients and graphics must remain smooth across folds or layered constructions. Barcodes, QR codes must scan flawlessly. And increasingly, brand protection features and anti-counterfeit tools or serialized elements must be integrated seamlessly. Digital presses deliver consistent, high-resolution output that ensures this level of precision. Result is not only visual quality, but compliance confidence and brand integrity as well. And in essence, extended content labels are about managing the complexity. Digital printing is a production technology that embraces that complexity rather than trying to simplify it away. It enables agility, it reduces risk, it supports regulatory responsiveness, and it actually maintains the premium print quality, all while allowing converters and brand owners to operate in 4 more flexible, data-driven ways. And that's why digital printing is not just compatible with extended content labels, it's actually the natural production platform for this kind of labels. Also, I want to illustrate the market size, and I looked at the projected size of the digital label market in general. This graph is expressed in billion square meters and runs between 2025 and 2030. And it will be no surprise that digital volumes are expected to grow. Now, if we add the forecast for extended content labels on this graph, and unfortunately, I could only find the numbers in billion US dollars, so not in the same, expressed in the same measurement like billion square meters, but actually, I just want to use them to illustrate the projected growth here as well. And actually, what we see when looking at these graphs, at these 2 graphs, is that this growth curve between 25 and 30, what we're seeing is not just a growing label market, we're seeing structural change in how information lives on packaging. The increase on digital label output and the rising market value of extended content labels are driven by a fundamental shift. There is more information being required and there is less packaging being allowed. So the growth you see on this slide is not speculative or trend-driven alone. It is the result of regulation becoming stricter. It is the result of sustainability targets becoming measurable. It's the result of SKUs becoming more global and digital production making complexity manageable. Extended content labels sit exactly, that's what's clearly visible here, they sit exactly at the intersection of these forces, which is why the market value is increasing in parallel with the global digital label output. Now, before going deeper into an example of extended content labels, I'd like to briefly position the broader landscape of these kind of extended content labels. There are several technical approaches to getting more information on a label. And today, within this presentation, I will highlight the three main methods, just to clarify the playing field and to explain where our focus will be. And the first category is the so-called dry peel labels, which are typically removable labels applied on top of the primary packaging. And the top layer can be peeled off cleanly, ideally without any glue residue. And often that top label carries promotional or functional value. And in retail, these kind of peel-off dry peel labels are frequently used for instant redeemable coupons or on-pack promotions. And the label drives action directly at shelf level. Dual side printing allows messaging both on the visible surface and also on the adhesive side. So you will see that often in retail applications. And then within this segment, I also see the so-called piggyback constructions also being quite common. Constructions where two labels are layered together. The top layer can be removed and can be reapplied, for example, to documents, to charts, to forms. An application that is widely used in logistics for track and trace purposes, and also in healthcare applications. For example, at blood collections, you will always find the doctor using these labels to mark the different sample use and to link them with the patient's information. A key characteristics of this category is removability and reapplicability. That's the piggyback labels, another example. Now, another method is the booklet or fold-out labels, and these are multi-page constructions that are permanently attached to a base label. These essentially function like a small book fixed to a product, and depending on the format, they can include a significant number of pages, in some cases 20, even 30 pages, or even more. Particularly relevant in highly regulated industries like pharmaceuticals, agrochemicals, where detailed instructions, a lot of information for use information must accompany the product. Advantage, of course, is that the maximum content capacity, the trade-off, is the structural complexity and the thickness of the label. These kind of solutions are designed when information volume, the amount of data that needs to be applied on the product, is very high and cannot be simplified. If it can be simplified, I would prefer the third category, and that's the one that I will focus on for the remainder of this presentation, which is the so-called peel and reveal, also known as peel and reseal labels, and often also called multi-layer label application. I will use the three different namings throughout my presentation, probably. These are multi-layer constructions where the top layer can be opened and can be resealed repeatedly. Instead of removing the label entirely, the consumer lifts top label to access additional content underneath. And typically, this kind of solutions offer 2 to 3 layers, which translates into 3 or 5 printable panels, which means in practical terms that an extra 200 or 400% of usable print area can be created without changing the footprint of the package. Important, as mentioned before. This format is particularly powerful for multilingual variants, ingredient expansions, regulatory updates, and variable data, and it balances the space efficiency with consumer usability and with production scalability. Unlike the dry peel labels, and the first example, the content stays attached to the product. Unlike a booklet label, the construction remains relatively thin and production friendly. And that's the reason why I will focus on this label application throughout the rest of my presentation. Usually, label converters do have almost all technology in-house to produce this kind of labels. There are probably more challenges for label printers that want to start with production of this kind of multi-layer peel and reseal labels. But I can see two major issues, or for some of you, possibly two challenges for you as a converter that you will have to deal with. And the first challenge is engineering the reliable multi-layer label structure, creating the sandwich, as we say, and combining multiple substrates, the adhesives, the print layers into a single thin, a functional label without compromising application, without compromising durability or user experience. The second challenge that I see is the accurate reverse side or the internal layer printing, or how to ensure the high print quality, correct orientation, correct positioning, precise registration on the backside or on the internal layers of the labels, often under tight tolerances and at production speed, of course. And then closely linked to this second challenge, also relevant to mention, is the registration, the usability, and the durability across layers. Think about alignment between layers, which is often, we're talking about very small labels that need to be aligned. Think of labels for nail polish or the labels for the small e-liquid bottles that are very popular these days. Also think about the clean opening and reclosing behavior of the layers. Think about ink and adhesive compatibility. Think about the performance through the complete supply chain. All these things you need to be aware of when starting with the production of ECL, extended content labels. So up to this point, we've looked at the extended content labels mainly from a market and an application perspective. And now I'd like to shift the focus to production reality. Because while peel and reveal labels look simple on the surface, the first major challenge happens long before printing even starts, as we just discussed. It's the creation of the multi-layer structure itself. And unlike a standard pressure-sensitive label, we are no longer dealing with a single printable substrate and one adhesive layer. We are engineering a laminated construction with multiple functional layers, printable face stocks, release coatings, adhesives with controlled peel strength, and a precise registration between the layers. Each layer now has a specific function. One layer must carry the brand and remain durable. Another layer must release cleanly. Another layer must reseal reliably. And all of them must behave consistently during converting, during die cutting, during matrix stripping, and during application. So the complexity increases further when you consider the tolerances. Layer alignment must be precise. Adhesive strength must be balanced, strong enough to survive logistic, but weak enough to allow repeated opening. The thickness of the construction must remain compatible with high-speed labeling equipment. So the first challenge in multi-layer application is not just printing, it is structural engineering. If the construction is not optimized, printing performance, finishing efficiency, and end-user functionality will all suffer. And that's why understanding the multi-layer architecture is foundational before we even discuss print technology. An efficient production of peel and reveal labels is not possible on a basic single layer converting line. It requires some specific capabilities and a precise integration of those capabilities. And the first essential element is a spot varnish station. Spot varnish, in this case, not for decorative varnish, but for a functional varnish. Spot varnish is typically used in multi-layer label applications to create the hinge area, and that zone where the layers must not permanently bond. I will make it clear later on if this doesn't sound strange for you. It defines where the label will open and how it will behave over repeated use. If this step is not controlled precisely, then the label either won't open clearly or it won't reseal properly. And after that, we move into the core structural step, combining the layers. And to combine the layers, there are generally two technical approaches. A first option is using the so-called crossover units in the converting line. Crossover units, that means that there are two layers of the peel and reveal label. Two layers are printed on the same web next to each other in one pass. And then the text on the back side is often printed using a flexo station on that converting line. Then the web is slit into narrow web, and the crossover unit, which is folding the label over two sides of bars, puts the webs on top of each other. Existing method, but of course adds limitation to the width of the final label, depending on the number of layers required. But the advantage is, of course, that only one roll of printed material is required. Using such method, it's clear that the multi-layer construct consists of only one substrate type for all pages. They all start from the same roll, from the same web. The other option is laminating two separate webs together, and that's the option that I will show later on in the remainder of my presentation. It is laminating two separate webs, of course in perfect register, and the advantage is now that a full web width can be utilized, and obviously that different substrates, different materials can be combined, as well as different printing technologies can be combined. Drawback of this method of in-register lamination is the reduced support for paper-based materials. And because these materials, paper-based materials, they do not stretch while laminating, which is required for in-register lamination, a little bit of stretch. Although new generation converting equipment can also solve this using servo drives. Now, once the layer structure is created, die cutting becomes the next precision step. And the cutting depth and the pressure must be carefully controlled to avoid cutting through the liner, of course. And after that comes slitting, rewinding, which might sound standard, but also with multi-layer construction, the thickness variation, the tension control, and the roll stability become far more critical. So while the final product may look like a simple label, the converting process behind it is significantly more demanding than standard label production. Efficient multi-layer production requires integrated converting capability, precise varnishing, accurate web handling, in-register lamination, controlled die cutting, stable finishing, and without that foundation, scalability and repeatability become major or may become major bottlenecks. Now, that was the first challenge, and if the first challenge is building the structure, then the second challenge is printing within that structure. And because in peel and reveal constructions, we're no longer printing on one outward-facing surface, we are printing on surfaces that will later be hidden, be laminated, and only be revealed when the label is opened. The reverse side printing introduces a different level of complexity, and we need to print on the inside of a layer, often in the glue side. We need to ensure that once laminated, the content reads correctly, that it is perfectly aligned with the front layer, and that it remains protected over the product's lifetime. Ink or toner adhesion, the curing, the registration accuracy, and the readability, they all become more demanding. So the second challenge is about printing information that will only be visible or often only be visible after conversion, yet must meet the same standards of quality, compliance, and brand consistency as the outer face. In short, reverse side printing turns a label into a three-dimensional communication system, and that requires a different production mindset. To illustrate a first method on how to get the content on the glue side, on the back side of the top layer, I will be using this example, and I will go back to a dry peel coupon, just as an illustration. But of course, same technology is used for multi-layer labels. First method consists of a back layer that sticks to the product's packaging. Often a transparent layer is used so that the packaging is still visible after removing the coupon, but one can also use a white label material and print some extra information that becomes visible after removing the coupon. And on top of this printed base material, a second layer is applied, which is actually a transparent layer. And on top of this transparent label material, the text for the backside of the label is printed in mirror text. On top of this material comes a top layer that contains the final image, a final visible image with the promotional text, with the promotional logos, pictures, whatever. So in the store, after peeling off the coupon to get the discount at the checkout, due to the release varnish in between, the peeling happens between the base layer and the transparent layer. The transparent layer sticks to the top layer, and the mirrored printed text from the transparent layer is now visible and readable throughout the glue. So that's a very quite simple, easy way to get text printed on the glue side. Many of our customers are doing it this way. There's also an alternative way, an alternative method to achieve similar result, but without the need of that transparent layer in between. It consists of adding actually two varnishes to the base layer. One is a release varnish, and on top of that release varnish, a static varnish. And on top of the static varnish, using a second pass through the printing press, we could add the text for the backside when printing in mirrored mode. And then later on, the same top layer is laminated on this construction. And here again, after opening the coupon during the peeling, the split is made between the release varnish and the static varnish. And the mirror text, remember the text that was printed on top of that static varnish, this mirror text transfers together with the static varnish to the top layer, and the mirror text becomes readable. Same result as before, but without the use of a transparent layer in between. And an extra advantage, which is often appreciated by brand owners, definitely for the dry peel coupons, is that the backside of the coupon is not sticky at all. And the glue is covered with the static varnish, and the static varnishes, the static forces will allow you to reclose the label if needed. From this point onward, I will take a closer look at the production process in more detail. And throughout the rest of the webinar, I will use this peel and reseal label as a practical example. The sample was created, already mentioned it, it's a fictitious nutrition brand, and typically products in this segment, in the nutrition segments, typically those products require a significant amount of information. They often require multiple languages, which makes extended content labels particularly relevant for this segment as well. And for those who would like to explore the workflow later on in more depth, a leaflet is also available that explains the product or all the production steps, the complete production process of this specific label. Production of this peel and reveal label looks very familiar to the production of the dry peel coupon that we used before. And we're also going to make use of the same technique as for the coupon, which means that we will be using the combination of a release and a static varnish to create a peel-off. Let's have a look at the different production steps. We start again with printing the back page, which is page 3 of the label construction. And on top of the printed back page, as we did for the dry peel coupon, we add the release varnish using a spot varnish plate. And a spot varnish plate is important, remember, to create the hinge that holds the pages together after opening. And on top of that release varnish, we apply the static varnish with the same plate. And then we print the back layer containing the two varnishes. We put that complete construction into the XEIKON press again. And for this example, we used XEIKON Cheetah or dry toner technology. And in register with the earlier printed pages, we will be printing page 2 of the extended content label, which is the page that later will be visible in the glue side after peeling off or after opening the construction. Of course, remember this page needs to be printed mirrored, since it will later be transferred to the upper page. Also important to notice is that often this page is only used for black text, since in conventional systems there's usually only one flexo station available for printing in the backside in the glue side. With this process, you can also print full color images, logos, photos in the glue side. In a separate pass, possibly on a different substrate, we can print the front page. For our example, we use, for example, a metallized label substrate as a front page, and we printed on it with Panther technology, which is our UV inkjet technology. Just to illustrate that with this technology, with this technique, we combine different substrates, and we can even combine different printing technologies. And the front page needs to be combined with the back page, which means in register lamination, and as a last step, die cutting and slitting, and the rewinding takes place. I realize that all this explanation may seem quite technical and not crystal clear yet for all of you, so I decided to show the complete cycle once more, but now in a more practical view, using the same example. Let's try. And we started actually printing the back page. In our example, it was a white PP label substrate. And as you can notice from the imposition scheme, 3 of the labels could fit in the web width. Black marker that you see at the bottom, that's of course crucial to get all future processes in register with this print. After printing, remember, we add the first varnish. And here you see already that the release varnish, and the one that will be responsible for the peel off later. Here you see already that we use a spot plate. We do not cover the complete sheet with varnish. Spot plate is used only to make sure that there is no varnish on the hinge area of the labels. If you want to know the details of the varnishes we used in this example, feel free contacting us. We have all the details and we can help you on that. On top of the release varnish, remember, with the same spot plate or a hinge, a static varnish needs to be applied. Remember that this static varnish will later be responsible for the fact that the backside of the label doesn't feel sticky, while still enabling the reclosure and the reopening of the complete construction. Then we put this roll of labels once more through the XEIKON engine, this time to print the back page, mirrored. That's just a setting in the workflow, so there's no complexity related to that. So we print it mirrored and in register with the earlier prints on top of the static varnish. On a different substrate, in the meantime, in our example, we used a metallized PP label substrate. We printed the front label. And for the sample, we used different SKUs. And we could print 3 SKUs next to each other on the web width. It's digital printing, so we could also change the SKUs over the print length. So we printed different SKUs, and we're almost there. This front page now needs to be laminated to the back page, of course, in register with the back page label, with the pre-printed labels. And with that, the rolls are fully prepared for die cutting, for slitting, for rewinding, and for final delivery. And as you may have noticed, one of the main benefits of this principle is that the backside of the labels, after opening, it is not sticky. The adhesive is covered, the glue is covered with a static varnish, which allows the label to close again thanks to the static charges rather than thanks to the exposed glue, which improves handling and which improves user experience. A second important advantage is the possibility to print digitally on the backside, which in the glue, which means that you can leverage full color capability, which significantly increases design flexibility and information capacity. And of course, as you notice, there are also some technical requirements to keep in mind. This method requires multiple passes through the engine for both the printing and the varnishing steps. And it also requires spot varnish application and precise in-register lamination to ensure proper functionality and alignment of the different layers of the label. And that's where my introduction in extended content labels ends. As already explained in earlier webinars on different topics, markets evolve, demands increase, and the converters who succeed will be those who design flexibility into their operations. Digital workflows makes this possible. It turns complexity into an opportunity rather than into a constraint. And the question is no longer whether digital printing can support extended content, it's just how you can leverage it to strengthen your business model. I hope today's session has given you some practical ideas and hopefully some strategic inspiration for how extended content labels can strengthen your offering and create new value for your customers. It's clear that this is no longer just a niche application. There are strategic enablers for compliance, for communication, and for operational efficiency. And let me close with a few key takeaways. First, extended content labels are clearly driven by market and regulatory pressure. Increasing requirements around serialization, multilingual information, transparency mean brand owners need more space without increasing the packaging footprint, of course. Secondly, this concept delivers both functional and commercial value. It enables regulatory compliance while also creating room for storytelling, sustainability messaging, extra communication about instructions, promotions, all within one smart solution. And third, the technical complexity should not be seen as a barrier, but as an opportunity. Yes, it's true, multi-layer construction requires precise adhesive and varnish compatibility, accurate print registration, in-register lamination, controlled finishing, but this is exactly where digital printing adds value through versioning, serialization, efficient short runs, which naturally leads to differentiation. Smart digital workflow and a strong digital front-end integration allow you to manage the complexity, to automate version control, and to produce data-driven jobs in an efficient and consistent way. And finally, this is more than just a label. It is a communication platform. The real competitive advantage lies in the material expertise, in the workflow automation, in the regulatory knowledge, and in the ability to offer complete end-to-end solution. As a final note, I'd like to invite you to continue the conversation with us and to invite you to our next webinar, which is a totally different topic, although relevant for our label converters as well. It's about the pressure around compliance, around migration, carbon footprint reporting, which is intensifying. And the regulations are tightening globally. Recyclability requirements are increasingly shaping packaging specifications. And converters and brand owners, they are still expected to deliver the performance, the quality, the profitability which they did before. On March 24th, so that's end of next month, my colleague Claude Depré will provide a practical guidance on how sustainability in printing and packaging are reshaping strategic decision making. We will discuss what actions are realistic and what structural changes may be required in the future. And we would be delighted to welcome you to that session as well. That brings me to the end of today's session. I want to sincerely thank you for your time and your attention. I hope you found the content insightful and valuable. And if you have any further questions or if you'd like more detailed information, please do not hesitate to reach out either to me directly or to your local XEIKON representative. We're always happy to help you. I wish you a fine day, fine evening, fine day, and talk to you soon. Bye.